So now I'm going to talk to you about dilations. If you've ever been to the eye doctor, they like to dilate your pupils, where they put some drops in and they make your pupils bigger than they actually are. So a dilation is something that creates similar figures. It makes it either bigger or smaller, depending on our scale factor. In the figure shown, triangle XYZ is the image of triangle ABC. The center of dilation is 0, 0, the origin, and the scale factor is XY to AB. Remember, it's image to pre-image. If the scale factor, if K, the scale factor, is between 0 and 1, the dilation is a reduction. If K, the scale factor, is greater than 1, the dilation is an enlargement. So this one might have been a scale factor of 2 or 3 because we went from a small picture to a bigger picture. That was an enlargement. So let's talk about how we accomplish this. If we're dilating from the origin, the process is pretty simple. You just multiply your coordinates by the scale factor. So if I've got this triangle ABC and I want to dilate it by a scale factor of 2 from the origin, all I do is I multiply all of my coordinates times 2. So if A is at negative 1, 1, I'm going to multiply both of those by 2. So negative 2, 2 is going to be A prime. My B point is at 1, 2, 1, 2, and I'm going to multiply that by a scale factor of 2 and get 4, 4. And there's B prime. C is at 3, 0, so I'm going to multiply those coordinates times 2, and I'm going to get to 6, 0. 1, 2, 3, 4, 5, 6. And if I draw this triangle, you should be able to tell by looking at it that it is bigger than the original. Now, one of the things we notice in a dilation is because the center of origin or the center of dilation was the origin, if I were to draw a line, looky there, it goes through A and A prime. So my distance to A was up 1 over 1. My distance to A prime was up 2 over 2 because the scale factor was 2. Same thing's true for B. I should be able to draw a line. Those of you art students who've done perspective drawings can relate to this line and the perspective of it. Point B was up 2 over 2. So B prime would have been up 4 over 4. And then obviously I can draw a line from C to C because they're both on the x-axis. But this was 1, 2, 3, and then C prime was 1, 2, 3, 4, 5, 6. Twice as much. So if you're dilating from the origin, you simply multiply each coordinate by the scale factor. So for this, it says dilate from the origin 3, negative 4 by a scale factor of 5. So we simply multiply each coordinate times 5. If I'm dilating from the origin, it's that simple. Now this one says dilate from the origin by a scale factor of 1/7. So this is a reduction. We're getting smaller. So we just take each coordinate and multiply it by 1/7. So B prime would be negative 14 times 1/7 is negative 2. 7 times 1/7 is 1. And that would be my dilation. And these are all from the origin. You just multiply by the scale factor. It is that simple. Now, number 4 says, what is the scale factor if the pre-image is 6, 9 and the image is 4, 6? Remember, we talked about the scale factor being image to pre-image. The new one to the old one. So the new one, the image is 4, 6. So I'll just pick the 4. And then the pre-image was a 6. So I reduce that and get a scale factor of 2/3. What if I picked the 6 and the 9? Well, let's look. 6 over 9, still 2/3. So to go from here to here, it's a reduction because the numbers got smaller by 2/3. Now here's the tricky part. If I'm not dilating from the origin, you're going to use the slope, kind of a rise and run between the point of the dilation and the coordinating point and the coordinate pre-image point. You still multiply by the scale factor of k to find your new image point. So let's show you what that looks like. If we're going to dilate this pentagon using a scale factor of 1/2 from a center of dilation of -3, 1. So let me go 1, 2, 3, 1. There's my center of dilation, not the origin. So you have to be careful when they change your center. So what I'm going to do is I'm just going to count to each point. I'm going to start to J. If I start at my center point and I count to J, I go up 2 and over 1, 2, 3, 4. So to get to J, I went up 2 over 4. So to get to J prime, I'm going to do half of that. So I'm going to start at my center point, but I'm going to go up 1 and over 2. Up 1 and over 2. And that's going to be J prime. Again, notice that there's a straight line running from my center point through my 2 J's. And I'm going to continue this process all the way through. So to get from my center point to K, I went 1, 2, 3, 4, 5, 6, 1, 2. So I'm going to do half of that and do 1, 2, 3, 1. There's K prime. The same for L. 1, 2, 3, 4, 1, 2. So take half of that, up 2 over 1. M is just straight over 1, 2, 3, 4. So I'm going to go over 2. And I'm creating a mini pentagon in this. 1, 2, 1, 2. And there's N prime. So I can connect all of these, make myself a little miniature pentagon, which should look just like the original. We're going to do the same thing for number 6. We're going to dilate LMNP from where it is by a scale factor of 2 from a center 2, 2. So we have a scale factor of 2, so it's getting bigger, but we're starting at a center of 2, 2. So we're going to graph all of these points. L is at 1, 4. M is at 3, 3. N is at 3, 1. P is at 1, 0. A little tiny picture. So I've got these points. Now my center is going to be 2, 2. So it's right there. So I'm just going to basically count a slope. And from there, I'm going to double it because it's the scale factor of 2. So to get from my center point to L, up 2 over 1. So you can double it, or you can just do that same thing again. Up 2 over 1, up 2 over 1. There we go. There's L prime. To get to M, it was up 1, right 1. So I'm going to go up 2, right 2. N, right 2, down 1, or right 1, down 1. So I'm going to go right 2, down. Let me try that again. Right 2, down 2. There we go. And to get to P, down 2, left 1. So I'm going to go down 4 and left 2. And when I draw this one, it should look about twice the size of the original because our scale factor was 2. So if the center of dilation is the origin, you just multiply your scale factor times your coordinates. If the center of dilation is not the origin, it's a different point, you're going to use your slopes and either double your slope or whatever the scale factor is times your slope. And that'll give you your new point.